Managerial Accounting, Regression Method of Separating Mixed Costs, Example 2. Now we've got a different set of data here as an additional example of regression and the value of regression in helping us to know whether or not we have a good model for estimating our total mixed cost. Now you're going to notice that this looks very similar to example 1. We've got January through June data, and also our pounds shipped is the same as what we had in example 1, but what's different is the shipping cost. So we've got a different set of data here because of the shipping cost information. Now let's take a look at what the regression results run on this set of data with these new shipping costs would be. Well, you see right away that we've got different information. Our total mixed cost for this set of data, our cost predictor formula, the intercept for this data is 85 pounds or $85. And remember that the intercept is our total fixed cost. So total fixed cost is $85 for this set of data. And that's quite different from what we got with example 1. And the slope of the line, remember, is our variable cost per pound. So our variable cost per pound for this set of data is 21 cents. I believe we got 18 cents for example 1, and that would be 21 cents times the number of pounds shipped, and we could use that formula to estimate our cost. But here is where I really want you to pay attention. Look at the R square. The R square for this set of data is only 0.51. Now remember what we said R square does. It ranges between 0 and 1, and the closer to 1 the better the predictor. So here we've got an R square of 0.51. It's a little over halfway between 0 and 1. And what does that tell us? It tells us that number of pounds shipped explains 51% of the change in total shipping cost. Now you may be saying to yourself, well, 51%, that's better than half. That's good, right? Well, think about it. You're trying to estimate your cost of shipping so that you can use it along with other cost data to set a price that's going to yield a profit for you. Do you want that cost to be accurate only 51% of the time? No, I don't think so. So this is not a very good predictor. The pounds is explaining 51% of the change. That means that something else may be changing or predicting the other 49% of the shipping costs. And what we might want to do is run multiple regression. Find some other activity measure besides pounds shipped and see if we get a better cost estimation formula, a better R square, if we use 2 cost predictors, 2 activity measures, rather than just 1. But if this is all we've got, then we're in trouble. This is not a good fit, because we can't afford to be right only 51% of the time in estimating our costs. So look for another predictor or an additional predictor in estimating our shipping costs. That's the value of the R square.